Integration 2, example 7. In my copy of the booklet, there weren't any limits here. You have a look and see if there's limits in yours, and if there are, you can substitute those in at the end. Remember to change them in terms of tan u, if there are. So here we've got x in terms of u rather than u in terms of x, so a slightly different approach. Rather than doing du by dx, we'll start by doing dx by du. X is in terms of u. If you differentiate tan, you get sec squared, and so dx can be written as 3 sec squared u du. Let's have a look at that 9 plus x squared on the denominator. 9 plus, now x squared, 3 squared is 9, and that will be tan squared u. Now that doesn't automatically look like an identity really, but if you take out a common factor, you get 1 plus tan squared u in the bracket. And hopefully 1 plus tan squared shouts at you as being sec squared using one of our identities from C3. 1 plus tan squared equals sec squared. So we now substitute everything in. We have a 1 on the numerator. That denominator, 9 plus x squared, became 9 sec squared u. And then dx we could write as 3 sec squared u du. Okay, so let's see what we've got. 3 on the numerator, 9 on the denominator, 3 over 9, that's a third. I'll take that out. And then we have a sec squared on the numerator and denominator, so they cancel, and that just leaves us with 1. So we're actually just integrating 1 with respect to u. So that becomes a third u, plus a constant. Now we don't actually have an expression for u, but we can find one. If I rearrange the original substitution, that was 3 tan u. If I divide by 3, x over 3 is tan u. And so if I do inverse tan of x over 3, that gives me an expression for u. So this integral actually gives us an inverse trig function. Now that's quite a standard result, and if you're doing FP3 this year for further maths, you may have done something similar with hyperbolic functions. So it's definitely worth making a mental note of these types of integrals that start x equals a function of u, because they do tend to end up being inverse trig functions like this.